Okay, so hello everybody. My name is Tarun, and today I'm going to show you how to make a sentiment analysis model. So basically what we're going to do is we're going to take a bunch of reviews of hotels that people left on TripAdvisor, and we're going to make an ML model that can predict whether the said review was positive or negative. So what I've done so far is I've imported a couple of libraries, NumPy and Pandas, and I have stored this data set which I found from Kaggle, and you can find pretty easily. If you just type TripAdvisor hotel reviews on Kaggle, you'll find it. I've loaded it into a data frame called df. So the first thing we'll do is we're going to clean the data. So first of all, let's see what we have in our data. So we can do that using, let's just see like the first 5 elements of the data frame. And you can see it has a review and a rating assigned to it. And the rating are on a scale of 1 to 5. So one thing we can do is we can try to see how the ratings are distributed, like how many 5-star ratings there are, how many 4-star ratings there are, and so on. So we can do this using a function called value counts. And I think it's important to see this every time. Just do some data analysis. And yeah, as you can see, 5-star ratings are the highest. There are about 9,000 of them. And then 4-star ratings and then 3-star. So pretty much what we expected. So what we can do now is we can decide which ones we can consider as negative and which ones we can consider as positive reviews. So I think a good estimation here is 1-star and 2-star reviews can be considered negative reviews, and 5-star reviews can be considered positive reviews. So now we want to change our data frame such that it only includes these 1-star, 2-star reviews, and it calls them negative reviews, and the 5-star reviews to be called positive reviews. So the easiest way to do that is to make 2 separate data frames. Let me just insert a cell below. So first let's create a data frame called data frame negative, for example, and let's only take the 1-star and 2-star reviews. So we can do this using a really useful command called .loc. So this just locates all the row-wise columns that fit into a certain criteria. So let's give the criteria as df of, square brackets, df of rating is lesser than 3. So now this df negative will hold all the reviews whose rating is lesser than 3. So let's just run that, yeah. And a useful thing to do whenever you make a new data frame is just to reset the index. So I'm just going to do that. Okay. Now let's make a data frame holding just the 5-star reviews. So we can do that similarly. Let's call it df5 equals to df.loc, where df of rating equals to 5, right? And again, let's just reset the index. What drop equals to true does is it doesn't store the old indexes, which is what we need. Okay, so now we have 2 separate data frames of just 1 and 2-star reviews, which is this one, and just 5-star reviews, which is this one. So now one problem is when we're putting this into a training model, if one of these are too heavily skewed to one side, that is, if one of them is much larger than the other, it's going to cause a problem. So let's see how many, and I'm assuming df negative will have much less. So let's see what is the length of df negative. Okay, it's 3200, And let us see what is the length of df. What do I call it? df5. Okay, so it's 9,000. So the problem is if we input this into a ML model, it's gonna predict, it's gonna be skewed and it might not give us good results. So one thing we can do is we can create a new data frame of just the 5-star reviews again, but taking just the first 3,000 or whatever, so that it's balanced, right? So that we have an equal number of positive and negatives. So again, we can do that using so let's create a new data frame called df positive this time. And let's set it equal to df5, again using the .loc. And we can take all the values from 0 up till the length of df negative. All right, so now df positive and df negative have the same number of examples, which is around 300. Let's just see length of df positive 3215. Perfect. Okay, which was similar to length of df negative, if you remember. So now that we have that, I think our work here is done. I think we've cleaned the data properly. Oh no. So one last thing we have to do is we have to concatenate all of these into one data frame, right? So let's call this data frame all. And the way you concatenate is it's a pandas function dot concat, and you open brackets and you type in both the data frames that you're concatenating, with in this case df negative and df positive, and you have to specify along which axis. So here we're concatenating them vertically, right? One on top of the other. So we do axis equals to 0. And again, let's just reset the index before we run it. Okay, perfect. So we have a df all. Let's just see how it looks. Let's see df all dot head. And yeah, so we have a bunch of 1 and 2 star reviews. Let's see the tail, which is the last 5 elements. It should be all 5 stars. Yeah. And let's see the length of df all. It should be around 6,000 something. Yeah, perfect. 6,429. So I think now the data cleaning is done. So the next step is to create a sentiments column. So which is basically a column that tells you whether it's positive or negative. So essentially, what we need to do is if the rating is 5, we give it a sentiment of positive, and if it's 1 or 2, we give it a negative. So we can do that using a NumPy function called np.where. So let's create a new thing called sentiment, a new column, and set that equal to np.where. Again, you don't have to remember all these syntax. You can just look it up on Stack Overflow or something, which is what I did. np.where df all of rating. So how np.where works is it is the condition that you want, for condition followed by what should happen if the condition is true, followed by what should happen if the condition is false. So let's say the condition is that the rating equals to 5, and then what should happen is, if it's true, is we should set it to positive. So let's just type positive, and else, this is the else case here, we set it to negative. Let's see if that works. Let's see df all dot head again. And yeah, so all of these got a sentiment of negative, and let's check the tail again, and all of these got positive. Perfect. Okay, so it's working. So now one thing we should do is, if you notice that all the negatives are at the start and all the positives are at the end, so we can just randomize the data set. Again, I had to look up how to do this. I don't remember all of this, but it is data frame all equals to data frame all dot sample frac equals to 1. And again, we will just reset the index after this. Okay, so now it should be completely randomized. And yeah, so let's take a look at let's see how it looks. Let's see data frame all dot head. Let's see the first 10. And yeah, perfect. So it's a random assortment of negatives and positives. And so it looks like it's working. So now the next step is to split these into training and testing sets. And this is really simple if you use sklearn. And if you don't know what that is, it's a really simple module. You can just import it. So I'm just going to do that from sklearn dot model selection import train test split. And okay, and I will, so the format is it stores xtrain and then xtest and then ytrain and then ytest. So let's just do that. Xtrain comma xtest comma ytrain comma ytest equals to, now it's called now we call the function train test split of. So first we have to specify what is the x. So the x will be the reviews. So we don't need the rating column anymore. The sentiment basically negates the rating. So the x column, which will store xtrain and xtest, is taken from df all.review, and the y column will be the sentiment. So df all.sentiment. Yeah, let's run that. This will take some time. Okay, perfect. So now you might be wondering, we have a bunch of text, right? Our x is just a string. It's just a set of strings. How do you input it into an ML model? So the way we're going to do that actually is using another sklearn model called Count Vectorizer. So to explain Count Vectorizer, I have the documentation pulled up here. So basically, suppose you have a bunch of sentences like this, right? So in our case, we have about 6,000 sentences. So in this example, there are just 4, and it's these, right? And what Count Vectorizer does is it stores all the individual words, like it goes through the list of every single word, and it stores every individual word, and then it creates an array, and it gives each sentence a separate vector, right? And it gives a vector based on whether or not it has said word. So this is the array of words, and these are all the words in all these sentences. And for example, sentence 1 is, this is the first document. So if you look at document is the second thing, and here document has a 1. And this is a 1, that means it has the word first. And sure enough, it does have the word first. Example, this is also a 1, that means it has the word this. Yeah. And this is a 0, that means it doesn't have the word and. And yeah, it doesn't have the word and. So this is how we input every sentence into the ML model as a numerical value. So let's do that now. So we have to import it from sklearn again. So I'll just write that as from sklearn dot feature extraction. The feature extraction dot text, sorry, import count vectorizer. Okay, and the next thing we're going to do is we're going to create an instance of this count vectorizer. Let's call it V. You can call it anything you want, count vectorizer. And So now we need to fit this to the x values, right? The y values are anyway just strings. Let's leave them as that. We don't need to predict on these, right? These are not words from the review. We just need to fit these. So first, let's fit x train. Let's create a new thing called x train vector. X train vector equals to v dot. So now what we're going to do is we're going to use something called fit transform. Again, you can see all this in the documentation. You don't have to remember any of this, but it's good to know it. And we're going to fit x train into this. So now basically x train vector stores all the numbers of the words which are present in that. And let's say x test vector equals to, now we don't have to fit it because we've already, let's just transform. V dot transform x test, right? Yeah. So let's run that. This again should take some time. Okay, that was fast. Now, so now that we have it in numerical data, all we need to do is we need to put it into some sort of classification model. You can use any classification model you want. You can look up logistic regression. It's really easy to run them. Once you have good data, it's really easy to just run them. So I'm going to use SVMs here. I'm going to use a linear kernel. So the code for that is from sklearn. I'm just going to import it first. Import SVM. Okay. And again, I have to make an instance of that. So let's call it CLF SVM equals to SVM dot SVC and kernel equals linear. Kernel equals linear. So now I've created an instance of this SVM, and now let's fit it to the x train vectors and y train. So we can do that using CLF underscore SVM dot fit of x and y. So what is x here? X train vectors and y train. And yeah, this should work. Okay, so it ran. So that means it's done. So now the crucial part, let's check the score. Let's see how good our model is. So let's do CLF svm.score. And this time let's take the score of the test modules. X test vectors and y test. And let's see what the score is. Okay, perfect. It's 95%. That means it's accurately predicting the test vectors to a 95% accuracy. 95%, sorry. And another thing you can do if you want is you can test the F1 scores. So basically F1 scores negates any sort of skew and bias or variance. So suppose we had much more positive reviews than negative reviews, say in like a 10:1 ratio. So what our model could have done is it could have simply predicted everything to be positive and it would have got a high accuracy anyway. In that case, our F1 score would have been low. So F1 score is the right way to check this, but since we have equal number of both, okay, I'll test it anyway. Let's see how high it is. So from sklearn dot metric import, it's always a good idea to import f1 dot score. Or is it f1 underscore score? Import f1 underscore score. Yeah. So now f1 score of y test and CLF underscore dot predict of x test vectors. In F1 score, the y comes first, I don't know why. And average equals to none. no module named sklearn.metric. Right, okay. So it's called sklearn.metrics, not metric. Um, and yeah, as you can see, the F1 scores are really high, which was expected anyways. Normally accuracy is not enough, but in this case, since we have pretty well defined data, this is enough. So now the most fun part is you can actually test this on your own reviews. So let's put a review of our own. Uh, let's say, for example, this place, again, these are hotel reviews, so use hotel words. This place was beautiful. Can't wait to come back. Okay, now again, we need to vectorize this. So let's call this review vector equals to v dot transform the review, and let's predict this. And I'm hoping the output comes as positive. Let's see. Oops, sorry. And yeah, it came as positive. Let's try a negative one. Let's see. Absolutely hated this place. Absolutely hated this place. Horrible food, for example. Let's run that. And yep, sure enough, it comes up as negative. So there you go. That's in that many lines of code. That's all it takes. You've built a sentiment analysis model that can train on hotel reviews. And the good thing about this code is you can do it for basically anything. You can do this, instead of this, you can take a spam classifier, stuff like that. This is very basic NLP, which is natural language processing. And you can use this code pretty much anywhere. So thanks for watching.